All right, Longhorns, this is the final test review for the 6 weeks, and this is our 6 weeks test. This test will also be the reassessment of the previous test if you did not pass last week's 6.2 test. So let's begin with problem number 1. Write out the first 4 terms of the sequence given by the equation a sub n equals 3 minus 4n. All right, so as you can see, what I've done here is I have plugged in for n 1, 2, 3, and 4. I've calculated each one of these to get the first 4 terms of this sequence. So when I substitute 1, I get -1, -5, -9, and -13. And that's all you have to do for problem number 1. For problem number 2, it says a soccer ball is kicked across the field at an angle of 30 degrees with an initial speed of 150 feet per second. Determine the set of parametric equations for the motion of the soccer ball. So here all you have to do is write the equations. All right, so the equations I have written here are the 2 parametric equations are x equals 150, which is the velocity, times the cosine of 30 degrees, which is theta, times t. And the y value is -16t squared. And this is because our velocity is in feet per second. So we're going to use the -1/2 times 32 feet per second gravity. So that ends up being this number right here, this -16t squared, plus the 150 velocity times the sine of 30 degrees, which is our theta, times t. And since there's no height, since plus h is 0, I'm just going to leave that off of my equation since I don't need that, since h is 0. And that's all you have to do for problem number 2. All right, for problem number 3, we have to evaluate this series. And so what I'm going to do is I'm going to go ahead and write out each term, add them together, and then I'll have my solution. The other option you have is to put it in the calculator, but I believe that Dr. Wren's students are required to do this by hand. So I may also require my students to do this by hand, even though you can put this in the calculator and get the same answer. You can put this in the calculator and check your answer using your calculator, but in order to do this problem and show your work, you're going to have to do this by hand. And I'm going to show you what that looks like. All right, so what this looks like is we take this equation right here, this 3m squared minus 1, and we plug in the numbers 1 through 6. It says, starting with number 1, do 6 iterations or 6 terms. So 1, 2, 3, 4, 5, 6. There are my 6 terms. I get my values for these calculations: 2, 11, 26, 47, 74, and 107. I add those together to give me 267. Now you can do the same thing in your calculator by going to Menu, Calculus, Sum, and that will give you the sigma notation, right here, and you would just simply plug in the number 1, plug in the number 6, and then plug in your equation, and then hit enter, and it will automatically give you 267. So that's the way we would do it in the calculator, but in order to show work, you're going to have to show these steps. So make sure that you do this on the test, otherwise you're going to lose points for not showing work. Okay, in problem 4, we're finding the center and vertices of the following ellipse. So HK is our center. So the center, HK, comes from our equation up here. And so this is H and this is K. But remember, we need to change the signs. So our center is going to be 2, -6. That's the first part of the problem. Then the next part is we need to find the vertices. Well, when it says vertices here, it means major vertices, not minor. So we're looking for major vertices. Well, the major vertices for an ellipse comes from the bigger of the two denominators, because that's which way the ellipse is being stretched. It's being stretched more along the horizontal than it is along the vertical. So since it's being stretched more along the horizontal, then it's the x value that's going to change. The y value is not going to change because we're looking for the major vertices, not the minor vertices. So only one of these is going to change. Only this x value is going to change. So when I take my center and I'm trying to find the vertices on each end, this y value is going to stay -6. But this x value is going to change. I'm going to add and subtract the square root of 16 to that. So I'm going to add and subtract a 4 from 2. All right, so what I've done here is I've taken this value for 2 and I've subtracted 4 to get the left end. And then on the right end, I've taken the 2 and I've added 4. So 2 minus 4 is -2. So my first vertex on the left is -2, -6. And the second vertex that's on the right is at 6, -6. Because when I add 4 to 2, I get 6. And that's it. We have the center and the two vertices. All right, in problem 5, we have convert the following polar coordinate to a rectangular coordinate. And our polar coordinate is 2, pi over 3. So this p right here in this coordinate right here, this is pi. So I'm going to rewrite this when I write it. I'm going to just use the symbol for pi instead of the letter p. But 2, pi over 3 is my polar coordinate. And I'm going to convert that to rectangular coordinates, an xy coordinate. Okay, so the first thing I'm going to do is write down my two equations. X equals 2 cosine pi over 3, which is my theta, and y equals 2 sine pi over 3, which is my theta. And I'm going to look at my unit circle and I'm going to write down my cosine and my sine for pi over 3. So cosine for pi over 3 is 1/2 and sine for pi over 3 is root 3 over 2. I'm going to use those two values to multiply times 2, my radius. So I'm going to do that right now and I will have my x and y coordinate for this polar coordinate. All right, so as you can see, I have 2 times 1/2, comma, 2 times root 3 over 2. Well, you'll notice that these 2's just cancel. They cancel out. And so what I'm left with is just the number 1 for x and root 3 for y. And these are my polar coordinates, my rectangular coordinates for these polar coordinates. All right, in this problem, I'm going to write parametric equations given the x equals 2 cosine t and y equals 3 sine t in rectangular form. So I have this set of parametric equations and I'm going to write them in rectangular form. In other words, I want to write like a circle or an ellipse or something like that for these two. So let's see what happens. The first thing we need to do is solve for sine t and cosine t. All right, so what we've done is we've taken the parametric equations, x equals 2 cosine t and y equals 3 sine t, and we solve for cosine t and sine t. So all we have to do to solve is just divide by 2. So we end up with x over 2 equals cosine t, and over here all we have to do is divide by 3, and we end up with y over 3 equals sine t. The next thing we're going to do is we're going to use this Pythagorean identity. This is just the Pythagorean theorem of cosine squared t plus sine squared t equals 1, and we're going to use this as our rectangular equation, and we're going to substitute in what cosine t is. So cosine t is x over 2, so I'm going to substitute that in. So I substitute it in and I write x over 2, the quantity squared, plus, and then I do the same thing for sine, y over 3, the quantity squared, equals 1. So all I've done is I've substituted what I solved here into this Pythagorean identity. And then I can simplify this. I have x squared over 4 plus y squared over 9 plus y squared over 9 plus y squared over 9 equals 1. And that's all you have to do for this problem, is just rewrite this parametric equations into rectangular form. So for the next four parts to number 7, we have to identify what kind of equation forms a circle, parabola, ellipse, or hyperbola. So you're just identifying this general form conic and what kind of conic it forms. And so there's some simple rules we can follow to determine what that is. If you have two terms that are squared, you have a y squared term and an x squared term. And if one of these coefficients is negative, only one of the coefficients is negative, then you have a hyperbola. If you only have one squared term, if only one of the terms in your equation is squared, then you have a parabola. If you have two squared terms and they're both positive, but they're not, the two coefficients are not the same number, then that's an ellipse. And you can tell the difference between a circle and an ellipse because these coefficients are different. So that means that this ellipse is stretching more along the y than it is along the x. So it's not a circle because these are not the same, so you're not getting the same stretch all the way around. This one's stretching more up and down. Okay, the last example we have is this one right here. In this case, we have two squared terms. These are both squared terms, and yes, there's negative signs here, but that doesn't necessarily mean that that's a hyperbola. Okay, if they're both negative and they're the same number, then that's not a hyperbola. This is actually a circle. So remember, if the terms are both squared and the coefficients are the same, it's a circle. All right, on the next section, this should be very familiar to you by now. This is the exact same problem we had on the last test. All you're doing is identifying the polar graph with its name. Okay, so the first one is the circle. Well, that's this one right here, graph D. The limison inner loop is the one that has a loop inside, and that is F. The limison cardioid is the heart. That's not this one. Some of you missed this on the last test, and you said that this was the heart and that this was the inner loop, the indented loop, but it's not. This is the heart, the one that goes in and touches the origin or the pole. If it comes in and touches the pole, that's the heart. That's the cardioid, C. The limison indented loop is this one here. I know it looks kind of like a heart, but it looks more like an apple. So this one that looks more like an apple, that's an indented loop. That's going to be E. The rose, of course, is the flower. That's A. The spiral of Archimedes is G. It's just a spiral. And B is the lemma scale, or the ribbon. We call this a ribbon. And that's it. All right, for problem 9, we're going to fill in the table and then graph the parametric equations. So all we're doing is substituting in 0, 1, 2, and 3 into our two parametric equations. And then we're going to graph x and y, and we're going to use arrows to show the direction. All right, so I have substituted in 0, 1, 2, and 3 into my two parametric equations. And I got for the first point negative 1, 1. Second point is 0, 3. Next point is 1, 5. And the last point was 2, 7. I graphed those on the graph, and I drew arrows to show the direction over time. And that's all you have to do for that one. Okay, in the next problem, we're going to fill in the table and graph the polar equation. I'm going to move this graph over a little bit so we can see it better. And I'm going to expand it a little bit. But our polar equation is r equals 5 cosine theta. And you should recognize that that is a circle. So I'm going to make this graph just a little bit bigger, and then I'm going to go ahead and fill in the table and draw the circle so you can see how it's graphed. Okay, so I've calculated 5 cosine theta for these particular thetas, and of course this p over 6 just means pi over 6, pi over 3, and pi over 2. And I've plugged that in here to my equation, and I got 5, 4.33, 2.5, and 0 for my r. And I went ahead and graphed these polar coordinates. 0, 5 is over here. Then 4.33 is just a little bit more than 4. 2.5 is right here. 1, 2, oh, wait a minute. Let me fix that. That's a little too high. 1, 2.5 is about right here. So since this graph is symmetrical, this one is also wrong. I need to erase that one. Let me fix it. 1, 2.5. So what this graph creates is a circle. And I'm going to do my best to draw a free-handed circle. And that's it. All right, so the last problem is the general manager of a fast food chain must select 5 restaurants from 8 for a promotional program. Order does not matter. How many possible ways can this selection be done? Well, since we know that order does not matter, that means we have a permutation. So for permutations, we're going to use the formula NPR, or in your calculator, it would be NPR, N comma R, or you might want to use the formula that's in the book, which is N factorial over N minus R factorial to find your solution. So I think we're going to go ahead and use the factorial solution formula to find the answer to this so that you can get all of your points for your bonus question. Well, n in this case is going to be the first number, which is going to be the larger of my numbers. So I have 8 choices. So I'm going to have 8 factorial on the top, and then I'm going to have n minus r, and r is 5 since we have 5 restaurants. So we have 5 to choose from. So we're going to we have 8 to choose from, but we're going to pick 5. So we're going to pick 5 out of the 8. So n minus r is going to be 3 factorial. So 8 factorial is just 8 times 7 times 6 times 5 times 4 times 3, etc. So if I write that down, and then I write down 3 factorial underneath it, well, these last 3 numbers just cancel out. So really what we have is just 8 times 7 times 6 times 5 times 4. And you can do that in your calculator, and you'll get the solution 6,720. Now there's a way you can put this in your calculator directly and get the answer. If you go to menu, and then you go to probability, and then you go to permutations, it'll actually give you this this notation right here. And then what you would plug in is you would plug in the 8 and the 5, and then you hit enter, and it'll give you 6,720. But I think if you want to get full points for this bonus question, you're going to have to show this n factorial over n minus r factorial formula, and then plug the numbers in and work it out by hand to get full points. If you just put down the answer from the calculator, you might get a point or 2 for that, but you're not going to get all of the points. And that's it. This is our 6th 6 weeks test, the last test of the year before the final exam. So good luck on this. I hope you all get lots and lots of hundreds and fives. Let's kill this test the way we did the last one. Do a really, really good job, and let's finish strong.